So we're looking now at question 5. Bryony suspects that a particular 6-sided dice is biased in favour of 2. She plans to throw the dice 35 times and note the number of times it shows a 2. So this is going to be binomial because it's success or failure. So I know it's going to be binomial, and they throw it 35 times, and if it wasn't biased, the probability of success would be a 1/6. So that's what I'm looking for there. And it says here, she will then carry out a test at a 5% level and find the rejection region for this test. So even though it doesn't say carry out a test, I am going to write all this information in just in case they're expecting you to see it. Because if you don't know how to write it in, then write it in. And P is the probability of getting a 2. It's always safer. If you know this information and you don't put it in, then you get really annoyed afterwards. We know N, we know the probability of success. So what we've got to do is we've got to find the region here that's 4%. And we've got to find this value. At what point, if she throws a 6 so many times or more, is the chance of that happening 4% or less? And so that's what you've got to hunt for. And it's quite a challenge to do, and there are 2 different ways of doing this. So I'm going to show you the 2 different ways. So this is the binomial CD, and if you get this, okay, you can easily make mistakes on this, so just be aware of that. It's very, very easy just to get things wrong. So here we go. Let's put in, we're going to select a value, we're going to guess a value. So let's just assume that x is going to be greater than or equal to 10. Okay? Now if I think it's going to be greater than or equal to 10, this does cumulative up to and including. So what I have to do is I have to say, well, it's 1 minus the probability that x is less than or equal to 9. Now we're dealing with discrete data, remember? So that kind of all does hopefully make sense. So what I've got to do is I've got to, let's go back up, start again. So my x value we're going to put in 9. I have 35 goes at this, and the probability of success is 1/6. So if I press that, I get to this value here, so 1 minus 0.94499, which is roughly 0.00, was it 00? No, 0.055, roughly 5.5%. So roughly 5.5%. So that's good, but I need to go, so that's just too high still. So let's try doing x is greater than or equal to 11, which therefore is going to be the same idea, but I'm going to go like this. And the beauty of that is that all you have to do now is go back up here, put in 10, go down, and you must equal it right at the end. You have to go all the way to the end, not before, because that's an easy way of making a mistake, and I know, if you know what I mean. If I did that, 1 minus 0.9761, you get to the value of 2.3%. And that's kind of what you want, because that is less than the 4. It's never going to be exactly 4, because we're dealing with binomial data. So your critical region, and you need to write this, is x is greater than or equal to 11. Now, there is a different way of doing this, and that's using the normal as an approximation. So you can do that. And if you want to do normal as approximation, then what you need to have is you need to set the thing up that says, right, here the mean is going to be NP and the variance is NPQ. That's how you do the approximation, remember? So I'm going to have it as NP, so it's going to be a 6th times 35. So I'm going to write that as just 35/6. And then my variance is NPQ, so it's 35 times a 6th times 5/6, which comes out, trust me on this one, at 175/36. And so now what I'm going to do is I'm going to see what percentage value, what's the critical value. So that's a great line. So this is again 4%. And there are lots of ways of going about doing this. I already know the answer is around here, so I'm just going to use that to help me. But what I've got to remember is, it's because it's discrete going to continuous, I've got to do a continuity correction. So I need a continuity correction, which is why I wanted to show this one. A continuity correction says, well, if I'm going to think it's going to be x is greater than 9, greater than 9, then I've got to actually say it's going to be, or let's say greater than or equal to 9, it's going to be x is greater than 8.5, because you've got to include the fact that it could be 8.6, which would round up to because it equals 2. So you've got to do the correction. Now I actually do know the answers here because we've just done them up there. So if I wanted to say, for instance, like if it was x was greater than or equal to 10, which was my first assumption, I would actually have to say 1 minus the probability that x is less than or equal to 9.5. So I'd have to go down that road. Okay? And again, you put it into your calculator, it will come out with the result that you're looking for. So it's a normal distribution. So here we go to 2. And what I've got to try and do is I want to work out the probability that x is less than or equal to 9. So I've then got to tally in here. So I'm going to put in minus 1,000 as my lower, and my upper is going to be 9.5. My standard deviation, it gets really messy, is going to be the square root of, and I get a bit panicky about this, so here we go, 175 all over 36, close that bracket, equals, and my mean is 35 over 6. Notice I haven't rounded anything up, otherwise I'd get silly rounding up errors, and I get that as being 1 minus 0.952, which comes to about 0.48%, so 4.8%. And trust me on this, if I did it as x is greater than or equal to 11, that would be 1 minus probability that x is less than or equal to 10.5. And literally what I can do probably, let's just see, yep, I can just go down, oh hello, go down to 10.5, press my equals, everything else is standard there, and I do 1 minus that, so that equals 0.983. So if I did that, I come out with a value of about 1.7%. And that is less than the 4%. So again, this is the critical value there. It's quite different ways of doing it. The reason I wanted to show you this was because of the continuity correction, and I think it's really powerful, and it's something you do need to know how to do as well. So hopefully that's helped you, and I'll see you on the next video.